Hold onto your hats, folks, because we're about to dive into something that sounds straight out of a sci-fi thriller, but it's happening right now. What if I told you that scientists are on the verge of reading your mind? No, I'm not talking about psychics or creepy mind control experiments. We're talking about the incredible power of artificial intelligence combined with the sophisticated technology of brain scans. It sounds unbelievable, I know, but the future is closer than you think, and it's absolutely mind-blowing in the most literal sense. Let's break this down. Researchers have been hard at work developing something they call a brain decoder. Think of it like this: every time you think, listen to music, daydream, or even just imagine a fluffy cat, your brain lights up with activity. It's like a complex electrical storm, unique to each thought and experience. A brain decoder is designed to capture that storm and, incredibly, try to make sense of it. The key piece of hardware is an fMRI machine, functional magnetic resonance imaging. You've probably seen them in hospitals, those big, tube-like scanners. They're not just for finding broken bones, they can also track blood flow in the brain. When a specific brain region is active, more blood flows there, and the fMRI detects that change. It's like watching the lights flicker on and off in a city, revealing where the action is happening. But here's where the real magic happens: artificial intelligence. The raw data from an fMRI is just a bunch of numbers and images. It takes incredibly powerful AI algorithms, think of them as super smart pattern detectors, to analyze that data and try to translate it into something meaningful. These algorithms are trained to recognize the specific patterns of brain activity that correspond to different words, phrases, and even entire concepts. It is a gargantuan task. Imagine trying to understand a conversation by only looking at the flickering lights of a city. It's a puzzle of staggering complexity. The AI has to sift through mountains of data, filtering out noise and identifying the subtle signals that represent actual thoughts. Now, the original brain decoders, while groundbreaking, had some serious limitations. They were like incredibly finicky instruments that needed a ton of custom tuning. Each person had to spend hours inside the fMRI scanner, listening to stories or performing mental tasks. Imagine being stuck in that tube, listening to the same audiobooks for 10 hours straight. It sounds, well, not exactly relaxing. And even after all that grueling training, the decoder only worked for that specific person. It was like having a highly specialized translator who could only understand one person's unique brain language and no one else's. If you tried to use it on someone else, you'd get gibberish. This made the technology incredibly impractical for widespread use. But here's where the story takes a dramatic turn. A team of brilliant scientists at the University of Texas at Austin has achieved a major breakthrough. They've developed a revolutionary new algorithm, a kind of universal translator for brain activity that can take a decoder trained on one person and adapt it to work on someone else with significantly less training. This is a game changer. They call this process functional alignment. It's like creating a map that shows how different brains, despite their individual quirks, respond to the same stimuli in fundamentally similar ways. They're finding the common ground, the shared language of thought, that underlies the unique patterns of each individual brain. To be a bit more specific, functional alignment works by creating a mapping function between the brain activity patterns of different individuals. Because, though everyone's brain is wired a little differently, there are enough similarities that one trained brain decoder can be used on a different individual with success. So, how well does this universal translator actually work? The researchers put it to the test in a fascinating experiment. They had participants listen to a brand new story, something the decoder had never encountered before. And the results were astonishing. How the decoder didn't get every single word perfectly right. It wasn't like a stenographer taking dictation, but it consistently captured the gist, the underlying meaning of the story. For example, if the story said something like, "She was a waitress working long hours at a busy ice cream parlor," the decoder might output something like, "I started a job I didn't enjoy, a lot of customers, long shifts." It's not perfect, but it's undeniably understanding the meaning of the thoughts. And here's where things get even more mind-bending. They discovered they could train this converter algorithm using data from people watching silent movies. Yes, you read that right, silent movies. This reveals something profound about how our brains work. It suggests that our brains represent ideas and concepts in fundamentally similar ways, regardless of whether we're hearing them in a spoken narrative, seeing them unfold visually, or even just imagining them in our minds. It's like our brains have a common, underlying language for understanding meaning, a kind of thought code that transcends the specific sensory input. This breakthrough has enormous potential, particularly for people who have lost the ability to speak. Think about individuals with aphasia, a condition often caused by stroke or brain injury that makes it incredibly difficult to communicate. Imagine a future where this technology could help them express their thoughts, their needs, their feelings, simply by decoding their brain activity. That's the ultimate goal of this research, to give a voice back to those who have lost theirs. It's about restoring connection and communication. Beyond the immediate practical applications, this research also offers a tantalizing glimpse into the inner workings of the human mind. It suggests that, despite our individual differences, there's a shared structure, a common framework, for how we represent concepts and ideas. It's like peering into the fundamental code of consciousness itself. So, while we might not be able to read every fleeting thought just yet, the progress in AI-powered brain decoding is truly remarkable. It's a field that's advancing at an astonishing pace, and it's definitely one to keep a close eye on. What are your thoughts on this incredible technology? Are you excited, concerned, or a bit of both? Share your opinions, questions, and even your wildest speculations in the comments below. Let's get a conversation started about the future of mind reading, because it's closer than you think. The future is coming at us quickly, and with technology like this, it is sure to be a wild ride. Stay tuned, because this is just the tip of the iceberg.